You know, every revolution has its engine. And for the absolute explosion we've seen in genomics, that engine, it's software. So today, we're going to do a deep dive into the critical system that was built to manage the incredible flood of data that's really at the heart of modern biology.
I mean, just think about it. From personalized medicine to agricultural biotech, sequencing DNA has completely transformed science. But all this progress, it comes with a huge challenge. Every single experiment, every sample, generates a truly staggering amount of information. We're not talking about a few data points here. We are talking about a literal digital ocean.
Right, so with data pouring in that fast, how on earth do labs manage it all? How do they keep track of millions of samples, make sure the results are accurate, and, keep the research moving forward without just getting totally buried? Well, that is the big question we're tackling.
Here's the thing. The single biggest bottleneck in genomics research today isn't actually the sequencing itself. It's managing all the data that comes out of the machine. The scale is just something we've never, ever seen before in biology. It's created this data tsunami that threatens to swamp even the most organized labs out there.
And to really put that scale into perspective for you, a single run on one modern sequencing machine can generate terabytes of raw data, okay? That's more data than thousands of high-def movies, all from one experiment. Trying to manage this with something like a spreadsheet isn't just hard, it's literally impossible.
So, to handle this data flood, a specialized solution was needed. Not just a simple database, but a really comprehensive system designed to orchestrate every single moving part of the lab. And this is where the hero of our story comes into play.
Say hello to the Laboratory Information Management System, or LIMS for short. The best way to think of it is as the lab's central nervous system, or maybe its air traffic controller. It's the one piece of software that connects everything. The samples coming in, the instruments running the tests, the scientists analyzing the data, and the final results going out.
Now here is a super important point. It's really critical not to confuse a LIMS with a LIS. A LIS, a laboratory information system, is all about the patient. It's what hospitals use to manage your clinical test results. A LIMS, on the other hand, is sample-centric. It's all about tracking huge batches of samples through these really complex research workflows. And honestly, understanding that difference is key to navigating this whole market.
All right, so what does this central nervous system actually do day to day? Let's break down the core functions that make a LIMS so completely essential for any modern genomics lab.
So the journey starts the moment a sample arrives. It gets a unique barcode. From there, the LIMS guides it through every single automated step, from prep all the way to the sequencing machine. It grabs the data directly from the instruments, which gets rid of human error, and then it manages those massive data files for analysis. What this does is create a complete, unbroken chain of custody, which is absolutely vital for things like regulatory compliance and just ensuring the integrity of the research itself. But it goes way beyond just tracking samples. A really robust LIMS also manages the entire lab environment. We're talking about inventory management that tells you when you're running low on key supplies, or equipment tracking that prevents costly downtime. It can handle super complex batches, it supports strict regulatory compliance with full audit trails, and it even generates automated reports. It's the whole shebang.
Now, with a LIMS playing such a critical role, it's probably no surprise that there is a fierce battle to become the software backbone of the modern lab. And this isn't just about who has the most features, it's really a clash of different philosophies for how to manage and control a lab's most valuable asset, its data.
First up, you've got the big incumbent, Illumina. As the biggest player in sequencing hardware, their Clarity LIMS is, of course, tightly integrated with their own ecosystem of instruments. It offers pre-configured workflows right out of the box. The strategy here is pretty clear. Give you a seamless experience as long as you stay inside their world.
But that walled garden, well, it has its trade-offs. Being locked into one ecosystem can lead to some major frustrations. In fact, verified user reviews frequently talk about clunky interfaces and slow performance, not to mention a critical lack of support that just creates a huge drain on productivity.
Next, you've got LabWare. Think of them as a long-standing titan of the industry. LabWare has been around for decades, and they offer an incredibly robust and comprehensive platform that's used by thousands of labs all over the world. It's really known for its power and its deep functionality.
However, and this is a big however, that legacy power comes with a cost. User testimonials often point to a dated interface and a steep learning curve. It often requires significant IT support just to get it configured and maintained. So yeah, it's powerful, but it's not always what you'd call intuitive.
So, in response to these challenges, a whole new wave of providers has popped up. Companies like Scispot are competing on a totally different playing field: flexibility, ease of use, and next-gen tools. They're integrating artificial intelligence and offering no-code customization, which basically lets scientists build their own workflows without ever having to write a single line of code.
And this table just lays out that strategic divide perfectly. On one side, you have a luminous closed garden, betting everything on tight integration. In the middle, you have LabWare's legacy power, offering all this robust functionality. And then you have the modern challengers like Scispot, who are betting on AI-driven flexibility and empowering the scientists themselves to build the systems they need.
Okay, so this brings us to the future. The battle for the digital lab is now being defined by a whole new set of trends, and we're moving far beyond simple sample tracking and more towards intelligent, predictive, and fully integrated lab ecosystems.
The future is all about being intelligent. We're seeing AI being used for predictive analytics, not just basic tracking. Systems are moving to the cloud for better scalability and accessibility. All these siloed apps are being replaced by unified platforms that combine everything. And there's this huge push to make data fair, which stands for findable, accessible, interoperable, and reusable, so its value can be maximized across different experiments and even different labs.
And look, this isn't science fiction. This stuff is happening right now. Take Scispot's AI assistant, which is called Scibot. It lets scientists ask plain English questions like, "Hey, what's the status of my samples from last week?" and get an immediate answer. This is what transforms a data management system into a genuine research partner.
So as we start to wrap this up, it's pretty clear that choosing a LIMS is one of the most important strategic decisions a modern lab can make. It goes so far beyond just picking a piece of software. It's really about defining how your lab is going to operate and innovate for years to come.
Ultimately, there's no single best LIMS. The right choice depends completely on your lab's core mission. Do you value the deep integration of a single hardware ecosystem? Do you need the raw power of a legacy system and have the IT team to support it? Or are you looking for maximum flexibility to future-proof your operations with things like AI?
And that leaves us with a final, kind of provocative thought. As software continues to eat the world, we have to ask ourselves, in the lab of the future, what's going to be more critical to discovery? The instrument that generates the data, or the intelligent algorithm that actually understands it? The answer to that question is going to define the next chapter of the genomics revolution.